Okay, in this lab you're going to build a scale made out of a cantilever with a strain gauge attached to it. And in this video we're looking at a top view of it. You can see that the strain gauge is sort of clamped to the edge of a table and we're loading it up with these different washers. So we're using a strain gauge as our sensor, and that's just a serpentine resistor that's printed on a piece of mylar, and the other end is attached to the circuit. So it's glued to this piece of aluminum bar, and we're going to attach it to the circuit later. It's fixed at this left end, close to the strain gauge, and then on the far end we apply force to the cantilever. And when this cantilever is fixed, what we get is essentially strain in the cantilever, and this is an exaggerated version. You can see that there's compression at the bottom and tension at the top, and the strain gauge is going to measure that tension. So the strain gauge is our sensor, and it's essentially a variable resistor. It will measure the change in length over the original length, and that is related to the change in resistance. That quantity delta L over L is called strain. So we're going to get an output of voltage versus the mass that we add to the cantilever. And our instrumentation is a little bit different than what we've been using before. You recall that we've been using the voltage divider, and we're going to use a kind of voltage divider in this case, but what we're going to do is take essentially two voltage dividers. I'm going to sketch it right here and put them in parallel with one another and look at the voltage difference between the voltage output of those voltage dividers. And this has a special name. This is called a Wheatstone bridge. And you can see that these are in parallel. They have the same input voltage, and they're both tied to ground at the bottom. So in a Wheatstone bridge, all the resistors are almost equal. We're going to use the strain gauge as a replacement for one of these resistors in the Wheatstone bridge. And what we want to get is some sort of scale that tells us whatever voltage we put in, it's a particular mass. And we'll need to get that through calibration. Before we start the measurement, we'll want to make sure the strain gauge is working. So on the resistance setting of the voltmeter, you might check your strain gauge, and it should be around 120 ohms. It's sort of difficult to handle. So it should be about 120 ohms if it's working. So this one happens to be a little less than that. We're going to add a little potentiometer. Now it turns out that this delta V is going to be quite tiny when we replace one of these Wheatstone bridge legs with the strain gauge. And to help us out, we're going to take that delta V and we're going to send it to an amplifier, which has some sort of gain that I designate with G here. So the output of this amplifier will be equal to the gain times that delta V. Okay, I'll confess to you that I slapped together a circuit and didn't do a great job, but I wanted to show you what it looks like when I'm trying to take the measurement. So I've got this set up on continuous acquisition, and you could see that I have, just dumb luck, the circuit is, the channel 1 is close to 0. I'm adjusting the potentiometer, and you can see that's why the line is going up and down. Now I want you to notice something. This is on a low resolution. If I put this on high resolution, this channel 1 shows plus or minus 2 volts. And when I go outside of that 2 volt range, notice that the line essentially goes dead. See, it's solid. So if that ever happens to you, notice that it's not a live reading. It's outside of the range. So what you have to do is either adjust it to get it in the range or go to the low resolution setting. Okay, so once again, I'm going to try to get it back to a balanced bridge. And you can see that I'm having trouble. I'll get it balanced, and then when I take the screwdriver off, it drifts from that value. And I think I'm going to go ahead and try to take a measurement just as it is. And I'm going to increase the scale on the y-axis so I can see changes in the voltage. And you'll notice now I'm going to try to balance it one more time. You'll notice that in terms of the time axis, I'm on the millisecond time frame, and really want to watch this thing over maybe a couple seconds. So I'm going to adjust that once I get this balanced. I didn't do a great job of building this circuit. I think if I were more careful, I wouldn't have so many problems here. So I'm just going to call this good enough. And you can see when I tap this, it bounces from the measurement. And now I'm going to adjust the sampling rate so that I can get a larger time frame. And I also like to back out so that I can see the whole buffer, because sometimes the line goes away and then I don't know when it's coming back. So I'm backing out. You can see, I can see the whole buffer here, the whole length of the line. And I'm dropping the sampling rate one more time and then backing out so I can see how long the buffer is. And you can see here when I flick the cantilever, I could see that it oscillate back down to a static level.